Hello and welcome to the open and free courses. This is Logic and Proofs, Chapter 6. And Chapter 6, as we can see, is all about derived rules and some strategic use of those derived rules. So, if we actually look through these things, we'll realize that we already sort of knew that this is the case. And the whole point of derived rules is to sort of give us a shortcut of getting where we know for a fact that we can actually get to, right? So if we have a conjunction, A and B, we know that it's functionally the same. It's truth table value exactly the same as the conjunction B and A. And the same thing with disjunction. A or B is the same as B or A. And so instead of having to for the conjunction, pull out the left conjunct and pull out the right conjunct and then add them up in the reverse order to get the new thing. This way, instead of taking 3 steps, we can take 1 step. Instead of having to set up a disjunction elimination, so that's step 1, and then solve each of the disjuncts by entering in values to the left and to the right, we can do that in 1 step. So that's really the benefit here. The associativity rule is again exactly the same. We can pull out each of the conjuncts and then add them up in a different order and get the different conclusion. And the same thing with disjuncts. We can pull them out one at a time and then re-add them up until we get what we want. So we know that this works. There's just no reason to take like 17 steps to do a problem if we know for a fact that the truth value of the situation cannot possibly change. So this way we can just get it over with instantaneously. Obviously, if you have a thing, you can add it to itself and you can disjunct it with itself. And of course you can do that in reverse. So not particularly interesting, again, except if you actually need to hurry up and get to a particular point in a problem. Distributivity is a fun one. So if we take a look at the distributivity of conjunction here, right? It says, so we have A and B or C. Well, in a conjunction, we know that both conjuncts have to be true. So obviously A is going to be true, and either B is going to be true or C is going to be true, or both. And so what we have is the conclusion that either A, which has to be true no matter what, and B, which might be true, is true, or, and now because this is a disjunction, either left side or the right side or both sides are true, or A and C is true. So there we go. Same thing over here with the disjunct. It's the same truth table, but you can actually just map this out as a truth table to double check that it does in fact work. And again, the whole point of using these things is just to make your lives a little bit easier. Unfortunately, at least in the sentential logic portion of this course, they don't really let you use the derived rules, right? There's an occasional problem where they go like, ooh, okay, here you can use it, but by and large, it's off the table. They force you to manually walk your way through every problem. This is really here so we know what's up. The disjunctive syllogism is actually a really, really important thing to know, and the reason why it is an important thing to know is because, quite frankly, it's a great way of setting up an argument. If we know that only 2 options are in front of us, right, A or B, then if we know that it's not one of them, right, it's not A, but either A or B had to be true, then there's only one option left, right? That kind of like saying, if you tell somebody like, hey, can you hand me that cup, and you go the blue cup or the red cup, and they say not the red cup. well, then there's only one choice left, so it's not really much of a choice, and so it's pretty obvious what's up. And now you can do that with not A, or you can do it with, if it's not B, then you know that the answer has to be A. Again, it's not very, complicated. It just sort of makes our lives a little bit faster. This is actually a really great setup for a number of very, very complicated ethics arguments where you can't know for a fact what the truth of the matter is. But what you can do is you can show that if you go in one particular direction, you're going to end up with such a contradiction that that side can't be true, right? And so we figure out what is true, not by proving what is true, by proving that the only other option, or at least apparently the only other option, can't possibly be true. So that's our sort of not Q, so to speak, and then you're left with the conclusion of P. The cut is a fun one. If you have two disjuncts and you have two disjunctions, and they both have a disjunct, the same disjunct except in a positive and then in a negative version, then that disjunct can't be true. So that one drops out, and only the other parts of the disjunctions remain. De Morgan's laws. This is another sort of fun, time-saving one. You will often end up with a negated something, and trying to get rid of that negation going forward can be rather difficult. So what you can do is you can just turn it into a disjunction of negations rather than a negated conjunction, or vice versa. Again, it's a pretty big time saver under particular situations. Modus tollens tells us that if the consequent of a conditional is false, then the antecedent must also be false. It's the only way to prevent the major problem. If you think back, for a conditional statement, there's only one way for it to be false, and that's if A is true, the antecedent is true, and the consequent, in this case B, is false. And if that is the case, then the entire statement here ends up being false. So if somebody tells you that the consequent is false, then you know that the antecedent can't be true. So if the consequent is false, that means that the antecedent must also be false in order to preserve the truth of the conditional. Let's see, transposition, right, off of the same idea of conditional statements. If you flip the position of the antecedent and the consequent and you negate both of them, you're still the statement is still true. Transitivity. This is a fun one. You have likely seen a hypothetical syllogism before. It'll say something like, oh my God, I don't know. If I go to the store, then I will buy food. If I buy food, then I will eat. And so, because the phrase "if I buy food" occurs twice, once as a consequent of the first premise and once as the antecedent of the next premise, you can just sort of drop it out, right? It's like in math when you're seeing the same bit show up as a numerator in one place and a denominator in another. They just sort of drop out of the equation, and so we're left like with, if I go to the store, then I will eat. And so ta-da, there you go. One step solution to that problem, instead of having like to work this backwards and then take like 4 additional steps proving a thing that is rather obviously true. Exportation and importation lets us play around with conditional statements and conjugations, as you can see. Definition of conditionals is all about conditionals and disjunctions, which is all about, again, it's all about just the initial truth table, right? The statement if P then Q will always be true if P is false, so that not P is true, or if Q is true. So there you go. Just a sort of relatively fast way to burn our way through this. Negated conditionals turn into conjunctions. We are, yeah, there's a lot of derived rules. I think 13 in this section, and you would do well to go through these and to work out the proof so that you have a sense of exactly how they come together. And if you can work out the proofs, then the next time you run into one of these weird problems, even if they won't let you use the derived rule, you will actually know how to derive the rule yourself. So that will save you quite a bit of time. Oh, this section here on completing derivation strategically is, I think, very important. Having a sense of conceptually what it is that you need in order to break a problem down properly is really important before you start pushing buttons or before you start trying to break things down. Because quite frankly, at this point, you have so many options that your odds of getting lost without the ability to sort of work your way through are pretty high. So first take a look at what you have, and that will give you a decent sense of what is it that you're actually attempting to do. So let's take a look at a couple of things here. Alright, yeah, so in this section they want us to use they want us to complete each of these derivations in two separate ways, once using the basic rules and then once using the derived rules. So let's take a look at them. Alright, so we're going to take a look at the problem here. We're going to solve it two ways. The first way is supposed to be without any derived rules, and then the second way is supposed to be with derived rules. So looking at this setup, how do we get to C? Well, I don't have a C anywhere that I could free up, so it's going to have to be negation elimination. So it's going to give us not C up top. I can immediately see that's going to free up the consequent here on line 3. So we're going to get that out of there. Alright. So now it looks like my target here is not E and D, and then what we can do is falsum, introduce this downward, so it's going to give me the opposite of this, the thing that I'm trying to achieve. And then working in reverse, we're going to do conjunction reduction in reverse. So now I need to get to not E and I need to get to not D. I can already see some fun combinations here between 1 and 2. So we have to do negation and reduction on each of them. We apply it here. Okay, so if we had E, then we can get this antecedent of line 2 through disjunction and reduction, this time on the left. And we need D as in dog. There we go. Now we can do this conditional elimination on line 2. That will give us B or A. Then we do a conditional elimination on B or A down to the falsum. And now we get to use our line 1 and introduce the opposite into each area. So here we'll do a not B, that's a falsum, and that gives us that contradiction. For line 12 here, for this box, we're going to pull out the not A, that gives us a falsum in that spot, Alright, so that justifies the not E. Now we have to justify not D. Now notice that D or E are on the same part of the antecedent in line 2, so it just sort of second verse same as the first. We do a negation elimination on D. Whoops, we don't. We do negation introduction unless we want to have additional work to do. That gives us D. With D we can do D or E. That will then allow us to disjunct, to eliminate the conditional there. Again, we're going to do disjunction elimination down to a falsum. Here again we get B or A, and again we do, we're going to take our line 1, right conjunct pulled out here, and that gives us a falsum. And again we're going to do the left side of that line down into the next assumptive box. That gives us the next falsum. And now we have justified the entire problem, right? This is 30 lines of justification off of 3 premises and a conclusion. So now let's take a look at how we can do this the second way, perhaps a bit faster. So as soon as I see line 1, I know that that's going to be a De Morgan's bit. So a conjunction of negations is the negation of disjunctions. So this is going to give me a not A or B. A or B. Looking at line 2, I see that if I could get not B or A, I could get the negation of the front side here. So first, we're going to use the commutativity of conjunction to switch A and B around. Alright, and now we're going to use De Morgan's on line 4. And there it is, there's the negation of disjunctions. Now we take a look at what we have here. Disjunctive syllogism on the left side. And if we apply that between lines 5 and 2, oh, whoops. That's what happens occasionally as you stare at things in a funny way. Where am I here? 1 second. There we go. It's the modus tollens. So we know that it's not B or A. So that's going to give us not D or E. We're going to apply that forward. Now that we have this is a negation of the, this is negated disjunction. That is going to be the same as a negation, as a conjunction of negations, which is what we have here. Ignore that first negation, because the two are now opposite of each other. So first things first, I have to flip this around with De Morgan's into a conjunction of negations, and then I need to flip them around because I need E to be in the front, so that's a commutativity rule here. There we go. Now the rule actually tells us that if we have a negated version of this, then we're all good. Now you would think that because the consequent of line 3 and my line 8 are negations of each other that we'd be good, but we're not. Because this rule specifically requires you to end up with one extra negation in front than what you already have. So we need a double negation introduction on this. There we have it. And now we need a modus tollens applied here. That should be giving us, am I looking at this correctly? Yep, that's going to give us negation of our antecedent. Now our antecedent is not C, so if we negate it again, we will get not C. and then we need double negation elimination, and that gives us C. Alright, so it took us 11 lines to do this with the derived rules, or it took us 30 lines to do it without the derived rules. And this is really where the derived rules shine. The trick is knowing when to use them, right? Fact of the matter is, plenty of times this is just going to sort of get in the way. You're going to start thinking about, well, what can I do here? Is this really going to work? What if it doesn't work? You're sort of going to get lost in the possibilities. So my suggestion is sort of get used to the way that these things transform. And I don't know, maybe flashcards or something might help, just to sort of get a sense for when you look at a function, like you should know at least that you can transform it into something else, even if you have to like pause and then refer back to your notes or something. But either way, it's a pretty good setup. What do we have here? Just a bunch of other problems. Alright, so here, for example, looking at problem, exercise 5, problem 2. I see that my premise 1 has the consequent D, and then my premise 2 is not D. So I know that if I drop that out, I'm going to negate the antecedent. So I'm going to get not A or not B. Now this right here, not A or not B, it is a disjunction of negations. And that means that I can turn it into a negation of conjunctions. So if I drop out D, I'm going to get not A or B. I can do double negation elimination. That will leave me with not A or B. Then I can De Morgan's that, and it's going to give me not A and B. And then I'm done. So it's that just getting that sense of like seeing these particular bits in there and being able to go like, oh, I know where this is headed, so to speak. Alright, that's really about it. If you have any questions or comments, I'm not going to ruin these for you guys. You kind of have to, honestly, you kind of have to suffer to solve these initially, and that really cements in the sense of what it is that you're looking at. Unfortunately, there is no substitute for just doing a gajillion problems on your own. One of the options that I will show you that you should know about is you can do this not on the official quizzes, but right here. Let's reset the entire thing. So the option up here that says tutor, if you just open the tutor by itself, let's see if it will let me. Oh, it won't. Huh. I wonder what the deal is. Yeah, normally it lets you. Alright, so for some reason it's being funky. One of the things to note, if you just open the tutor and you don't have anything selected, the tutor is not going to be very helpful. But if you select a particular goal and then you open up the tutor, or when the tutor is open you click on a particular goal, it will actually be rather useful. Right? It will ask you a bunch of questions. It's sort of plain 20 questions to solve a logic problem. And it's a pretty decent way. If you get stuck and you're like, I don't know how to do this, you should be able to pull it out that way. Alright, if you got any questions or comments, leave it in the comments or shoot me an email. and I'll see all of you next time. Take care.